Okay, yeah, I can see it. So shall I begin? Shall I begin?
Yes.
Okay. No one else is coming here, is it? Okay. Chun Xiang Lai. That's you though. Who you might want to mute your mic. Oh, it's a cute pic. Ivan, no preamble, no anything. Just begin.
Oh, okay. Here we'll be having last meetup on July 2019, Malaysia. And Patrick, the one you see in front.
Can you not what's that, show your video so that people know who's talking? Because right now no one knows who's talking. You have to turn on your webcam. Ivan, you do know how to turn on your webcam, right? Okay, good. Unmute yourself as well.
Here will be. Here now will be on Rust Meetup, July 2019. And today the speaker will be Patrick from the CTO from Rust. And he'll be talking about, later he'll discuss what he'll be talking about. Okay, now let's start.
Okay, hi everyone. Okay, so today is going to be a very, very simple talk. So the what I wanted to share really quickly is just the how to get started with using Rust with WASM. So one of the key things that people like to use, one of the key things that people usually say that using Rust is very good for is actually because it's a great it's great to compile it to WASM, because WASM is like the web assembly language. It's one of the, let me just pull it up so that everyone can see. Yeah, so basically it's an open standard for targeting compile languages to target in the browser, and it's already kind of GA in the major browsers. So now is a really good time to sort of get started learning it and get started with using it as well. One of the cool things about it is that because it's a compiled kind of binary, you get some of the benefits that you don't get when using, say, JavaScript to script your browser. So things like being able to directly access memory and directly manage memory, as well as low-level graphics. Yeah. So I'm going to share today the kind of steps that I had to use in order to get started with with Rust and WASM. I'm going to be pulling very much from this book here, which is very useful. Basically. Oh, right. Sorry, it isn't sharing my screen yet. Okay. Okay. Grab a chair. Yeah. Yes. No. Use those. There's two there. Yeah. Okay. So let me just share my screen real quick. Okay. So to reiterate, I'll be sharing about kind of basically compiling from Rust to WASM. Yeah. Very, very simple. Basically sharing how I got set up with it, basically, because it's not as easy as you would hope as of now.
Wasm in Rust should be the most mature, theoretically.
Theoretically, yes, but it's still kind of a bit of a messy thing to get it working with like actually having it in the browser finally showing. Yeah. So this is the kind of angle, and then we can continue further on if we have extra time basically. So getting started, first of all, you need to have the Rust toolchain set up. So the first thing is basically making sure that Rust Up is available. For me, because I'm running Arch, Arch Live, so it was just as easy as yay Arch, yay Rust Up, and then I had it there already.
I thought we should install from official installer, right?
No. I mean, you can also install Rust directly from the official installer, but it doesn't. Using Rust Up has some niceties to it. Basically, it makes it easier to do a bunch of stuff. So once you install Rust Up, then you would specify the distribution. So when I initially installed Rust Up and I tried to run like Rust C version, it basically gave me an error saying you haven't defined the version yet. So let me actually go back so that you can see that. Yeah. There we go. No default toolchain configured.
So you're using the Rust version?
Yes. So then you just have to install the stable version and then also set it to be default. So once you do that, then that makes it the default toolchain. Okay.
Rust is like OS testing, right? It's not cross-compilable.
No, yes, I believe so. So this one is specific to, well, so it did install the Rust version for x86-64 Linux GNU there. So
you can install the master Linux also can.
Okay, yeah.
You change to stable Linux.
Okay, I defer to the masters on that because I'm still very new to this. But I just did it for Linux and that's it.
You can just type Rust Up toolchains list, then you can see the list of toolchains that you can install.
So what was it like? Just Rust Up
toolchains
list.
Toolchain. Yeah.
Freaking plurals, man. Okay.
You can
dash all.
Okay.
Yeah. It's okay. We'll get back to that as and when we need to. Okay.
Oh no, Rust Up target list. Sorry.
Okay.
Okay, is the one you install.
Okay, cool. So yeah, first of all, have your Rust toolchain set up basically, and then you also want npm to be available because you're going to use npm to actually connect up the Rust generator WASM library with the web side, and then you also want you want this tool called WASM pack. So this actually functions a bit like Webpack for WASM. So it helps to kind of compile WASM it compiles the kind of Rust stuff that you do create into like a package with like a package.json.
Transpile.
Yes, not just transpile. So it creates the WASM, but it also creates the wrapper around it that browsers will need to actually load that WASM in, basically. Yeah. So this is all generated by WASM pack. Yeah. So
but do you like transit like AES5 running on this type browser running on like supports everybody?
I believe it, because of WASM itself, is only supported by evergreen browsers right now. So you kind of no need to target, because basically it's like, okay, if you don't support promises, you probably won't support WASM, yeah, or any of the other things. Yeah, so installing this is very simple. It's just a matter of curling, except I realized that it tries to write to user bin by default. So you need sudo here, but don't sudo unless you know what it's doing, obviously. Yeah, or sudo, I should say. Yeah. Okay, great. So that's pretty much the stuff that you need. You just need Rust Up, npm, and then you need the WASM pack. Okay, I've taken a bit of a fast track because of what I did is I used Cargo Generate to actually generate a template project from GitHub repo. So let's explore the template project real quick, right? So the template project comes with these two files here. So lib.rs is the actual Rust code that will be running. So let's just zoom in on this so we can see. And what it does is set up some global allocator stuff and then specify a function which will greet later. And this extern here is to call out to JS. So WASM bindgen actually is like, think of it as kind of like the bridge between the JS side and the WASM side. So because there are two different targets to the browser right now, they're still trying to figure out like how these two are going to interconnect. So as of now, for example, JS can access the linear memory that WASM uses, but WASM cannot access any JS objects. So when you try to, in order to access any JS objects, you need to use this WASM bindgen basically. You can think of this as like being the bridge between them. So if you want to call things like window, document, all these other things inside a browser, you would use bindgen.
Only if you want to use like this external libraries, right?
Yes.
I thought if you let's say don't need to run external JS,
yeah,
your WASM is running.
If it's self-contained, then yes. So, but nonetheless, if you want to paint a canvas on the browser, you still need to use it a little bit.
Okay, they don't have that concept inside the.
Not yet. No. So DOM models and everything all are not something that's in Rust by default. Yes.
It's not like they are targeting to ready automatically like that for the bindgen tools.
Yes, exactly. So it would require Rust to know a lot more about what are the target that you're actually targeting. Yes. So as of now, Rust itself doesn't compile the stuff. It's WASM pack that compiles it. So that's why it kind of doesn't know as much. Yeah. So as you see just now, I basically just ran WASM pack build. So what WASM pack build does is it generates this package, which gives you a package.json. It gives you a TS TypeScript. I'm not entirely sure why it gives you TypeScript. Unsure as of yet.
Yes, is that the auto-complete thing?
B.ts, yeah, this is the TypeScript definition, but it also, okay, so what you're saying is this is actually a TypeScript definition for each of these things. Right. That's interesting that it gives you a TypeScript definition for the WASM file. Strange. Okay, but anyways, and then you have this thing which basically imports the WASM and then defines the actual function that will be called later. And then finally, to use it in a web project, you need this like, you need to also import it from the package and then actually call the function. So there's two levels of indirection here. This is calling .greet. .greet is actually defined in here as this, and then this is actually calling this here. So, I mean, you could technically bypass that one level of indirection, I suppose.
But your ID will say like auto-complete and things like that.
Yeah, it should, yes. This is all generated, by the way. So everything from the PKG here is all generated. And everything inside of the WW here also is, this is a, what do we call it? Where's the package? Here we go, yes. Yeah, so this is just basically like, think of like CreateRack app. There's also a CreateWASM app, basically, that like has all the boilerplate that you need in order to consume Rust generated WASM packages. Yeah. So if you did all those steps right, then you can basically inside of the www folder, run npm run start, and then yeah, you have your Rust app running inside of the browser. Yeah. Okay. Any questions so far?
Well, since the operating then we still might expose itself to like JavaScript for like all those undefined things like that.
You would have to, yeah, I would imagine, and especially if you're building a WASM app, very rarely I would imagine you can build only purely WASM. You would probably still need to interact with jQuery and like with all the other things. Yeah. So yeah.
But I mean, we tried other things where what was the other one? Is it Elm or they also have something similar, like it's bridging. I mean, it's not WASM, but
Elm?
yeah, it's all like bridge. JavaScript or something like that.
Is that a totally different language? I thought Elm, I thought Elm is like just transpiling kind of the same way TypeScript does.
They can call and they have some bridge for JavaScript as well.
Oh, okay. Oh, okay. So it like actually generates the code. So by the way, that's pretty much it from me, actually. Yeah.
What if you find you do any WhatsApp in like other?
We're looking at it right now for a chat or processing library on the front end. So one of the things that actually I'll show you data trust. Hold on. RustLang/data.
So you're facing challenge with current sort of like charting libraries or?
Yes, they are very slow. Yeah, so I'll give you an example of this one here. So our current charting system it looks like this basically. So but this is quite limited. We limit the number of charts already in here. There's actually a lot more chart types. And the reason why we limit it is because of if you push like 1,000, 1,500 charts into people's browsers, generally their browsers don't like it. Yeah. Also, as you can see, there's various different chart types as well. So we were kind of thinking about whether it would make sense to actually do the drawing with WASM and just have them all be canvases so that you can GPU accelerate the shit out of it.
Oh, last time I think there's a tutorial, there's one on the Game of Life, right? Then take the whole canvas out, manipulate on the WhatsApp side.
Yes, exactly.
But don't they have like a WebGL kind of equivalent in the JavaScript?
There is WebGL, but WebGL is actually harder to code because you have to do shaders and all that other stuff.
They don't have like a layer or something that can come up with a
I mean, there's a wrapper for this. Is the best wrapper is D3 lah. Yeah.
Oh,
yeah.
A bit funky, right?
Yes.
Another one there.
How about e-charts? E-charts.
E-charts.
Yeah, I think the same mentioned that as well. They follow from the Baidu or whatever. And now the English version.
E-charts.
Yeah.
They're a charting library?
Yeah, charting library. From Baidu or one of the big China.
Chinese documentation.
No, now the English, last time I did it, I didn't but now they're doing it.
Oh, Apache.
I thought everyone can read Chinese here.
I did programming languages.
I like the radars. What's the performance like?
I have
Okay.
what was that one?
Let me personally, right? There's a very good reason why most finance applications are still using desktop. Yeah, it's because the web, even though the web democratizes access to it, no one has been able to get web charting to work really well.
Correct, right? Even such a small screen, you'll be very hard to even manipulate, right? It's like you don't have a big view as we have something like this. It's like nice.
You can. So we tried that with the charts that we have, right? If we want to assemble a dashboard that's got like 10, got like hundreds of charts on it, and it just slows the fuck down.
Yeah, I mean, even if you can squeeze it in, but it's like for you to even see the big picture, it's like you zoom out and like.
That's why you zoom. Yeah. So that's one thing one possible way that you can actually use WASM on the front end very nicely. Obviously, people have talked about games. Games, doing game programming and shipping games directly to the browser. There's, I think, another project that actually compiled WASM to run in the browser it's a kernel. It's a minimal kernel running in the browser, which is quite cool. And then, another thing that we are very interested in actually would be the statistical analysis side. So if you can do math very fast in the browser, that would be nice. Yeah, especially math related to ML. Yeah, so if let's say you have access to low level graphics programming, right? You could potentially foresee doing things like neural network training in the browser directly. Yeah.
But for the ML part, right? They say there's are we data science yet? Remember there's a website. Are we data science yet? They talk about the Rust for data science. Even though there's not many helper libraries available.
Mm.
People use the raw, just using the pure Rust, the performance is already very good.
Yeah, yeah. So one,
Your problem is always libraries and there's so many Redis.
Yeah.
They have a big community. The closest one I see will be like the for performance one will be like the Julia, the Julia folks, Julia. Yeah, in terms of trying to balance the performance and your ML and
yep. Yeah. Have any of you guys done any Rust to Wasm stuff?
I did only on the tutorial.
Okay.
On the game of life.
Okay. Anyone on the live stream have any questions or any comments? Okay. Okay. Yeah.
Anything special you found out? Or
the toolchain is not as simple as I thought it would be. My thoughts were originally when I thought about it was like, oh, the people were pushing Rust as like the best experience for using the WASM, right? Turns out it was not as simple as I thought it would be. Still, you still have to piece multiple pieces together. Like I showed just now, right? You kind of have to have a bootstrapper for your npm side. You also have to have a we're not yet at the point where I can just drop a WASM bundle into a browser, into an index.html, just script module type WASM include the WASM, and then it just works.
I remember WASM just that do auto generate those do code for you, right?
Sure. I do think that the pace of change right now is quite faster as well. So that's why maybe there isn't an established way of doing things yet. Yeah. We are also very, very early in our exploration of Rust as well. So yeah, one of them, like I said again, one of the main reasons we're exploring it is just purely for charting, for being able to ship kind of like good data applications directly to the user browser.
What about Mozilla? Do they have anything that they're using it in production?
Mozilla?
With WASM, since they are the creator of Rust.
Let's try and see. That's Wazi. I don't think so. I mean, they did that POC where they ran Firefox in Firefox, right? Was it? Yeah. Ivan, any cool things that you saw people do with Rust, with WASM?
I think U is written in WASM.
What?
U framework, the Rust front-end framework.
Oh, okay.
YEW. Yes. Yeah, this is one of the framework that is like client side. I believe this is wasn't. Yeah.
It's pronounced Jew. Or no, you. Okay. It says that uses web workers. Oh no, yeah, WASM and Rust.
Yeah, there's some extraction there. It's like kind of similar to the React Randall. It's not template based. It's still like abstraction based.
Oh damn, that is pretty sexy. Yeah.
But because of the type checking and the macros, so the command type is low.
Oh my god, all the hipster buzzwords, man. Inspired by RustLang, yeah. But yeah, one of the main things that we are struggling with right now is we need to support IE 10. So we need to have an efficient way of like switching out anything we do in like WASM. We need to have a way to target like non-WASM capable as well.
The show.
There's not the things that WASM does, right? There's no polyfill for it. Yeah, you need linear memory. I guess that's mscript 10, but like it's very old. And I actually didn't test 1.36 with mscript 10. I don't know if it still works or not as well. Yeah.
You showed the static picture there, and you want the cool stuff.
Cannot.
Huh? You are continuing the presentation, right? Or should we let him to take over? Just take like some questions. Do you have any more questions? Okay, do we wait for you understand? Do you have anything else?
Nope.
Or you share more?
You want what would you like me to share more about?
Is it the documentation? Everything is in the guide, right?
Yes.
You don't need to go internet to search for some issues.
No, that's one thing that I really love about Rust though. The documentation is very arch, like everything is in the art, everything is in the wiki.
Do you check with your community members through
IRC?
Yeah.
No. I've been only use IRC.
The IRC channel is going to be closed by Mozilla. The
Okay.
Mozilla IRC channel it will be closed. So people are last time I checked, people are still deciding to move whether to Discord or this one more.
Spectrum.
No.
Not Spectrum. Why not Spectrum?
5 character. I don't know what but 5 character.
Yeah. There's a very, very nice page here on JavaScript operation that talks about what you need to do if you want to import and export JavaScript functions.
So I mean, you guys are like the expert in like JavaScript, so but then when you want to use it together, wasn't you struggle with the Rust part of it, or can you reuse a lot more of your JavaScript knowledge stuff in there?
Nope. Rust is very un-JavaScripty.
There's one guy writing the one the link you shared.
Yeah.
The guy writing in JavaScript.
Yes.
There's something like operability.
So
after that, same like a Python oxide, running Python on the browser.
Yeah.
In fact, it's powered by Rust on the back. Is it? I remember.
Okay. In any case, I mean, Oxide sounds like a perfect thing to be Rust, right? Yeah, exactly. But because the name Oxide is probably related to Rust. No, actually, the language that is much more JavaScripty, I think, is Dart. Excuse me, RustLang. Dart, like what is used to write Flutter, yeah.
So what's your experience using like Dino and things like that?
Oh, Dino is great because you just write JavaScript. You don't need to write any Rust.
It's not like
it's all JavaScript.
Transparent to you.
Yeah. Dino is really nice. Very, very, very excited for how much people are in the community are like, contributing to it. I believe it should be very stable soon, actually.
Yeah. So I heard they wanted to libraries like from Go, right? They followed the thing and things like that.
They moved from Go to Rust as the base. Yeah.
Oh, so originally they were using Go.
The original proof of concept that Ryan wrote was in Go.
Oh, I thought it was always in Rust.
So it has a V8 engine, and then the actual system interface is in Go. But now he's rewritten it to Rust.
But still, the libraries all are like based on Go. Yeah. Libraries.
But yeah, I don't know how long it will be until 1.0 release. But yeah, because we're an enterprise now, we have to wait until 1.0. Yeah.
But there's no, I mean, because they don't have full Node.js compatibility, right?
Yeah. They don't aim for full Node.js compatibility.
So do you miss any other function?
No, this is beautiful because you realize that basically the structure of it is exactly like browser JavaScript. So I don't have this issue with fetch is not available. Like all these other inconsistencies that Ryan introduced with Node.js.
Okay, so it's exactly the same like a browser.
It's exactly like a browser. Yeah, which is very beautiful. Yeah. Yeah, really, 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 really nice project actually. Yeah, it's very exciting.
We can even talk about it next time.
The thing is, a talk about Dino will be mostly TypeScript and JavaScript, not Rust. I don't know enough about Rust. I don't know enough about Rust to.
Some example of Dino in production.
You use it for production?
Huh? No. It is nowhere near ready for production, bro. There's security issues all over the place. Yeah, look at that. Look at the number of issues. Would you feel comfortable using this in production?
See, issue levels.
Fixed time apocalypse in timer.js. Like, what the dude? Yeah.
Anything else to read that?
Yeah, you can let. Okay, thank you very much. Yeah,
Thanks a lot, Patrick.
very simple talk. Yeah. So I will disconnect. You want to come here and plug in?
Yeah, it's okay.
You want to grab a chair to sit there, or use the screen to let them see?
Yeah.
That's why I said you want to come over here and plug in. Oh, sorry, Ivan.
Okay, so now we will be okay. Okay. So now. Yes.
Alright. Hello everybody. I was asked to do a quick Rust 101 to get people on board in programming Rust. So I'll start by by running interpreter-ish thing called eraser.
Why not the Raptor is our always use the Raptor.
Yeah, it's
What do you see?
Raptor.
Oh.
Was Google's 20% project. Yeah. So they have a repo here. This is a real repo.
But this is not built into the Rust command line.
It's not
separate one.
It's a separate crate. So you need to do a cargo install in order to use it. And yeah, it's a real repo instead of the one you see on repo.it.
Oh.
So you start it by this. Okay. So when you start programming, the first thing that you want to learn is usually hello world. But I will start with the concept first. The first one is assignment. So usually you will want to assign a value into a name. So for example, in Python, it will be something equal to a value. So in Rust, you do that similarly, but just a little bit of difference. Like you have a let keyword, and then you have a name, identifier, mutable.
Is it the same like JavaScript like concept?
No. There's only difference here.
Or doing for
Let
let immutable immutable. So contrary to other languages, so if you write this statement, the immutable variable that we call it cannot be changed. The value cannot be changed. So if I attempt to
assign another value to it, it should throw me an error because by default, a variable cannot be modified, manipulated of an identifier later when during the program execution. You need to add a keyword here, mute, to the assignment. So, for example, then this should work. Right. So
It's saying wrong because it's actually compiling and running and then getting the response. Okay.
It's a bit slow. Yeah. Then we would have, this is for string, and then we would have numbers. We can do the same thing for numbers as well. So if you can see from the previous example, I did not specify any data type into the assignment because by default, data type is implied by the compiler. So if you want to explicitly specify the data type the variable, you can do so by putting a column. I want a number now, so I 32 equals to 10. They are only for strings into a variable without specifying the data type. By default, it will be, for integer, it will be i32, but Rust also supports 64-bit numbers although. For other data types that is supported for integer, you can refer to the Rust programming book.
iSize, right? iSize.
Yep. You use iSize when you usually want to access certain elements within a list, for example, that will never have negative numbers. That's when you use iSize. It's specified in the documentation in the chapter here. These are all the list of integers that are supported.
For 120.
Yep.
Oh, but 120 is a bit, this year, I think that stabilized is around, I think around Rust 1.28.
Okay.
Or 1.3 something, just like recently.
Oh, is it I did the unit as a joke?
Huh?
1.28 and I 128. Okay, no.
It's somewhere around there.
Okay.
Sure, I made a mistake. So just as I said, iSize, it's actually usize when you define the usize whenever you want to access maybe an element in a list or a specific character in a string. Use a usize because it is always positive, unsigned numbers.
And this is also where the safety comes in. Compared to C, you have integer for everything.
Yeah.
Usually people just use INT, right?
Yeah.
But it might be different. INT might be different in different systems.
You don't want a negative access for an array, that makes sense.
But there's U as well. For unsigned.
Got it. Okay.
So as mentioned just now, if you
So i32 can have quite a big number, right? So I would assume that if let's say you assign x without the type to a really large number, it would choose i64 or i128 depending on the size of the number automatically.
not too sure about this, but
Type addition is it called?
but by default, if you accept if you put in a reasonable big number, then it should be, it's always defaulted to I32.
Okay.
You can, yeah, we
You can
can
try it.
if you want.
Yeah, I'm not sure. It's okay. Thanks.
So like I mentioned just now, if you don't put explicitly state the data type, it will be defaulted to I32. So
Wait. So
sorry.
it's not defaulted to I32. It depends.
No, it's stated in the documentation.
Is it only
Let me show you. I don't remember when I saw it. I
because
saw it.
it will automatically type cast, I remember.
Okay, I'm trying it now. So I just name a number that is above the theoretical maximum for 32-bit signed binary.
It's always default to 32.
Last time I tried when you just put a number inside the array, it will automatically defaults to U size. Because it depends on there's type, what they call type addition or something like that. So from what I've learned is that there's something like, so that you don't need to specify the type, they automatically guess the type for you. The compiler will do that. So most of the time you don't need to put the type yourself. But yeah. Okay. That's why now.
Right, yeah. I'm just sharing from what I know through the documentation.
Oh, okay. Yeah, actually, there is a.
Yeah. Ooh, okay.
So it actually doesn't.
You actually remember the.
Oh no, I just looked it up real quick. You wish I remember.
I thought that's a lucky number or something. I thought that would be a lucky number or something.
No, man.
For floating point numbers, the default data type is F64. So if you I leave out the data type, it should work the same as well. So in this case, let's put 5. Alright, it's a bit slow. It's slower than I initially expected. Okay, then we have booleans. Truth, true, the work. Unlike Python, everything is in lowercase. Same for false. So there are only true and false in Rust. There's no none or whatever. None is handled by an enum that I will not be covering, because you will be using none for other purposes rather than determining the true value. So you can also do maths thing in Rust too. So you can have this.
Is there a not a number type?
Yeah, the string.
Okay.
Oh, not the number NaN?
Yeah.
None.
What word is?
There's infinite, but not a number. I'm not sure.
What type is infinity?
So
Infinity is a float type. Okay.
I've not gone that big yet, so I'm not too sure. So I'm showing you here the way we cast things. One thing I don't like about type language is there's a lot of casting that needs to be done explicitly. Because
you can't do math when it's not the same type.
Yeah, coming from Python, this is
Very
very
annoying.
close. So this is how you do mathematics. So all the basic mathematics should work. And then we have lists or array, depending on where you come from. So we can have a list of number 1, 2, 3, 4, 5. We can also have a list of names or strings.
oh, the one that don't call is the point array, right?
Yeah, in Rust we call this array, but yeah, everyone names different things differently. So
Yeah.
But there's the difference between array and vector.
Yep,
Right.
that's something that I'll cover next. So for now, this is how basic array lists look like in Rust. So like I will say just now, there's a difference between string and like str and string and vectors and arrays. However, usually if you want, there's a very convenient way like to manipulate them because what I defined so far, the strings and the arrays, they are not mutable. Like you cannot change whatever that's inside. So if you want to manipulate them, if you have plans to manipulate the string or whatever that's inside the array, you define it differently and they will be allocated in memory differently also. So
I remember that
So these should be on the stack, right? When you allocate
Yeah.
yeah.
I remember array is mutable. You can mutate array, but you cannot change the size.
something like that.
So you can mutate the individual elements inside of it.
Yeah.
But you cannot change the size.
Yeah.
But I mean, couldn't I, if that's the case, right, couldn't I create an overflow by large thing inside of element of the array with two elements?
What also?
Oh, you also
So when you, yeah, so let's say for example, right, you put two things on the stack, an array of this size on the stack, right? You're expecting that these two values, these two pieces of these two values are only going to be this size. So couldn't I break things? Because the rest is all about safety, right?
Yes.
Yeah.
But you need to check whether that could be if that fits into the size of the integer. The array will also, but I think the integer might overflow.
What's the what's the maximum size of the string in Rust?
You mean string or str?
Whatever you call it.
Inside there we call it str because it's static.
Okay. Okay.
And string is a heap allocated string.
I see. So anything in stack is str.
You can make a string, you can derive a string into
Okay.
You can also make str a string.
I understand, but what I'm saying is when it's on the stack, it's in by default str.
Depending on how you define the string and the list. If you define it this
The
way,
answer is it depends. Okay.
yeah, because the syntax is different when you define it.
But like that is on.
And
In
also,
this case, it's a str.
also when you define a string and a list,
Uh-huh.
the size needs to be fixed. It needs to know, the compiler needs to know at that time how big it is.
Okay.
So the size of array cannot be something that is mutable, cannot be a variable.
Right.
For instance.
Under the hood, how is it?
So it's always fixed and always predictable. So if you plan to change the capacity of the list or string, or if you want to push things into string in future, so the way you do this is you define them differently, and usually you start by defining them in this way, because they come with some methods that helps you to manipulate them, for instance. So once this is done, you can do things like please go faster. push.
of the manipulatable.
The manipulatable versus manipulatable.
Oops.
So this is the equivalent of concatenating.
Yep.
Yes. You can also put a single character. Push and
Cannot. Oh yeah, yeah. Needed to.
so
Yes.
it's immutable by default.
Yeah, you also need to define it to be mutable.
No, but if you do this, will they take away from your safety check or whatever? It's shadowing. So it should be.
Yeah, it's shadowing that I'm supposed to cover next.
Yeah.
Yeah.
This is okay for me to just put this to anytime I see error, I just put this person. As long as you let and you define, you override basically.
Yeah.
Yeah, this should move now. Okay. Yep.
We should simple print first.
Wait. So we have yeah, if you want to print the result, yeah, because by default push string does not return anything. So if you really want to see what's happening, I failed typing. So this is how you print things, and the syntax looks somehow like the format, string format in Python.
Right.
Yeah. Okay.
Yeah, this is a macro.
Yeah.
Hence
This is the first macro that you see. Anything that is followed by a exclamation mark is macro. So the reason I make this macro because print line is made to accommodate multiple types of things. So I think they find it easier to implement it as a macro. So we have also vectors, which works kind of similarly like a string here just now. So if you plan to manipulate the vector in future, so this is the second macro that you see for the day.
Just make it mutable first.
No, I'm not doing anything to it. So this is how you define it. Yeah, if you want to push in things, like you need to make it mutable by putting a mute in after that here.
What's special about macros versus functions?
Sorry?
What's special about macros versus functions?
For function, you can only set specific arguments they put, and the types must be the same.
Okay.
Macros, you can make the macro to accept any number of arguments.
So also is a general case of a function.
Because what happens here is they will expand the macro into a huge pile of code that handles everything you expect it to do, like accepting different type for different case. Because here,
how is that different from a function?
Because if you make it a function, then it can only deal with one type of data. So if you have
So a macro is basically it's like a special case of function that can deal with lots of different things.
Yes.
That can take in multiple numbers of input.
Arguments or different types.
It's kind of like an interface or generic, yeah. Maybe go generate.
The macro is something like a C macro.
What's the C macro?
The C.
Just trolling. You don't have the right to ask that question.
Because macro, right, there will be a function inside macro, so when they call that macro, they will run a function to generate more code.
Like Roger.
What other languages have this concept? C?
I don't see it in Python, so
Python does.
I don't know. I don't see it in Python.
Okay, right.
Yeah, because that's my primary language right now.
I don't think Python has a concept of macros.
No.
I have not seen that. Or rather, all functions in Python can be macros because they all take in whatever you want to throw in.
Because it's dynamic, isn't it?
Yes. It's the same with JS as well. I'm trying to think what like use case as a macro fulfill that a regular function doesn't, and I realized that actually yes, in JS there are overloads. So actually in JS you can have each argument can actually take in anything you want. Yeah, so then you have no need for macros because of yeah.
But in Rust, you
Yeah.
can use macro for a lot more things. But
Yes.
yeah, but I will not be covering that because I don't have that much time.
Rust macro is not like C macro where you just expand, literally just expand the code. Rust macro they run through the Rust function, so they use the Rust function to generate code. In this case, what we do is they will initialize a vector with the size of 2. So it will be optimized rather than you do yourself and pushing in one by one.
Got it.
Okay, so it will like behind there is something behind the scenes.
Okay.
So shadowing, I sort of covered it just now. So shadowing works like this. So it can also shadow things in different type. For example, if I have this string, then I should not show this in the interpreter. It's not that obvious. So let's say let's get out of the interpreter for a while. Okay, do I have this? Let's say I start a new project. Sorry. And then projects. Yeah. It's going to take a while.
Oh, you're using remote stuff.
Yeah, because I'm running Rust inside WSL. Because it makes it easier to set up.
Yeah, I heard it's really good actually. We were thinking about looking into that for developing inside WSL.
It's a lot of workaround that's needed, especially when you run Docker. But otherwise, it should be fine.
Right.
Oh, I thought it was like native now, right?
I heard that in the internal discussion, right? They say Docker is slow. Like Docker, all those
Docker cannot run inside. You can only run a client inside WSL right now. But they are coming out with WSL 2.
Docker is slow and that is not nice.
No, the fuse mount is slow.
The what?
The fuse. Docker is using the fuse.
Oh, fuse mount, right.
If you do lightweight workflows, it's okay.
No, Docker doesn't work in WSL at all.
Oh.
It cannot run inside WSL.
Because of the kernel calls.
Yes.
Yeah.
You can install a client in here.
Yes.
And then Docker has to live in actual VM outside of
That's the
WSL.
Docker for desktop.
Wait, is this the new one?
Yeah, the new terminal, which is kind of not usable.
Not usable? Why?
But I don't have any better.
They released a really cool promo video for it.
Yeah, but it's not finished right now, so it's like half done.
It was like a full promo video looking at it.
For instance, I cannot configure it. I'm not even sure whether the settings are like actually like.
Oh my god, it's a JSON file.
Yeah, I don't even know whether they actually
read it.
work.
Right.
Yeah,
Okay.
yeah, it's still beta.
Okay.
Right. Okay. I want to show shadowing. All right. I need my cheat sheet on. Okay, let. So if I print here, I would expect a string that says hello world. However, I can also like in the middle of the execution, I can change it to something else completely, like change it to a number.
And you only to be simple, you just use DBG and then the variable name. Yeah, you want support multiple argument in Rust. So 1.36, the latest release, right?
Do you want one more?
No, it's okay, it's okay.
So the latest release, 1.26, they support multiple arguments. The 1.35 or 1.36, they support multiple arguments for DBG.
Oh, okay. Oh, that's new. I don't know why. Yeah, because Rust is not my primary language.
So for this one, you can just type DBG, then exclamation mark, and just the variable name. Yeah.
Okay.
It will return the original value, so you can even put it inside here.
Wait, will return the original value?
Yeah, so you can you can.
DBG should work like this. This is the shorthand for DBG, is it?
Yes, but you don't need to put it on this line. You can put DBG on the pen itself, the value pen.
Yeah, this is a shorthand for the DBG should be a shorthand for this language.
No, you can even put DBG on here. You can put DBG here.
Okay, but that's not what I need to debug. I need to show shadowing. Yeah, you can change the value to something else that is not relevant to what you defined initially. So shadowing is kind of useful when you have scope. Like for instance, you have some other things going on inside block scope. So now I want it to be a string. So now it should print out a string. But once I'm out of the scope, I should be expecting the last that I define here, which is 10. Let's try. Please run. Oops. Please run. Yep. It will back to the last value that I defined.
Sure.
Right.
This is also how the lifetime works. Lifetime.
Can you see the output?
Sorry. Yeah, there's an output. It will go once this is out of scope. Once the block is out of scope, it will fall back to the previous one.
Interesting. So, is there any way to actually set a value and have it?
Sure.
Is there any way to set a value and have it propagate outside the scope?
No, because it will be shadowed.
Right.
We call this shadowing.
Sure.
The value will be dropped there.
What if I make?
Because if you put everything inside.
Let's say I make this new.
Yep.
Let's say I make this mutable. And then after that.
It will be always shadowed by the latest declaration, the latest assignment.
Yes, so
it doesn't matter if I have mute or not here.
Okay.
It will still work.
Yeah, the same output will be there.
It will respect
But
it.
if I remove let here, then it would work.
It will not work.
It will not work.
Because the type is different.
Okay. But if the type is same, it will work.
Yeah, because if the type is, if I put this 12.
Okay. And then you remove let, then it would write the assignment. Okay.
So unless there is exception, like it is string, if there's a lifestyle thing.
Okay. Okay, got it. So this is the only way to have value.
No, in this case, can because it's integer. Integer is copy.
I understand.
The train copy.
Yeah.
But the others that only have the trade code without copy. So there will be you can run. See. So if you change to string, you can see what happened.
This should be the string.
Yeah, this one is here, this string.
Okay.
So you cannot just put a string on it.
No, in this case, because everyone wants to demonstrate different things, so it has to be this.
Then you click on as big as.
Oh, is it a macro?
So no, it's not macro. So it is a short form for string from.
Is it string double colon, not single?
Yes, string.
Yeah, and there you put just string single colon.
String colon, one colon.
Where?
Line 5. Line 5.
Double colon, right?
One colon you put.
Double colon.
From before from.
Oh, okay.
Yeah.
Yeah, screen typing sucks.
But the error message is not that friendly.
Yeah.
Because there's
Wait, what's happening now?
okay, this is the lifetime.
Okay, right.
Lifetime.
That's not implemented copy tree. Oh, is this like pass by reference, pass by copy, pass by
No, because the okay, here maybe I should.
Wait,
Let me explain.
I'm not covering copy that soon yet because
This lifetime thing.
yeah, copy is different thing that I want to talk about later.
Okay, got it. Yeah, sorry about that.
This is how they keep us secure.
But yeah, since it's brought out, a very quick mention. Copy trade is all is applied to types that are usually allocated to the stack. For instance, numbers, and then remember when I said when you define a string or arrays that needs to be in fixed and known size. Yeah, these are all copy traits. These are all things that implement copy trait. Copy trait is treat it as something like class for now. Yeah, but I will not be digging it any deeper than that. Yeah, it's just an interface or class, something that implements certain methods. Yeah, we take it as an interface or a base class in other languages.
Yeah, almost kind of like a type composition.
Almost that.
Yeah.
Almost yeah.
Okay. Yeah.
Yeah, but I'm not going to dig any deeper than that because it's a lot of things to talk about when we go that deep. Okay. We can also define a range of values for example, 1 to 100.
This is including this one.
So you will have sorry?
Oh, no, just like Ruby started with one. Like, why did they have to be special?
The equal is for inclusive.
Oh, exclusive. Oh,
No,
okay.
if you do not have the equal sign, it will be up to 100, but not.
That's pretty cool. Yeah, okay. Forgiven.
This was something new, like Rust 1.2, something around there.
How's the backwards compatibility in Rust versions?
Rust version is always backward compatible, except at 2018 edition.
Okay.
But now they introduced something that they introduced back the non-lexical lifetime feature NLL to the previous one. Because there's some parts where the lifetime doesn't work that well.
Okay.
But they introduced this new thing.
In general, you can expect Rust to be backwards compatible. You can treat Rust as something that is mature enough that would not be receiving much syntax change in the future. Yeah. So if statement branching, now we talk about branching, which is mainly the if statement. It's nothing too fancy. It's just this something that returns true value. And we do something about it. You can also have else, if, else. And then note that whenever you see a block inside Rust, you can treat this as an expression. So whenever you see a block here, so in this case, we have three blocks that are tied together within the if statement. So if you decided to return something from here, you can return things here. So like you can return a number. So if you decide to return a number here, you will have to make sure every branch of your code returns the same type of things. Otherwise, the compiler will complain. Then you can, yeah. This is mainly, then we have looping. Looping is simple, also very similar to what you have in other language. 1 to 100. Like you can do GI. Nothing too fancy here.
Any off equivalent? In JavaScript now you have off, which allows you to iterate over objects.
Or functional stuff.
Yes, you have that also.
For off is very interesting because it's not technically functional stuff.
Oh wait, for off.
Yeah. For I off. So I can put in an array that, let's say I have an array of names and do for name.
Yeah, this is for off.
This is for off.
This?
Yes, it is for off.
Okay, so how do I want to iterate through with indexes instead? Okay.
Something like Python, right?
You can do that, but I'm not sure how to do that in this syntax. You can do looping in multiple ways. This is one of the ways.
Okay, so this is for off. This will pull out 1, 2, and 3. Okay, but if I wanted to go through an array with and get 0, 1, 2, 3.
Yeah, you can do that. I can show you.
Yeah,
I will show you that one. That is possible also. You can they have something like the enumerate function in Python. You can attach index to the value when you look through the values.
Okay.
Is that what you wanted?
And next, so is that's kind of like a generator ish.
Kind of.
Not familiar with yeah, okay. I'm not too close to generator.
This iterator is lazy.
It's lazy.
Yeah, it's lazy, yes.
No, they have
So
this
it
enumerate.
is considered generator. Oh wait, no.
They have this enumerate.
Enumerate function. Inside iterator. User FUNC colon enumerate.
It will attach the index of the value into the
Okay. Oh.
yeah, we touch on that.
Yeah, so this is more like a generator, yeah, okay. Or iterator, yeah, got it.
usually when you need to go to this enumerate, you will not be writing your loop in this format.
Sure, yeah.
I'm just showing.
Yeah. So you just for and then inside that you call next and then.
No. Okay, maybe you show.
I'll show that later. Come down. The last thing that people usually do in programming is creating function. So when you create a function, the syntax is not too fancy. Also, you will have this followed by a list of arguments. 64. Yeah, everything inside the arguments needs to be defined very explicitly. You cannot expect the compiler to imply what the data type is. The compiler needs to know when you create a function. So we define the return type like this. So in Rust, the last expression is always return, so you do not need to explicitly write a return here. So you can just leave it. CS 64. This will work. Then you pass in numbers. This is how you call it. Nothing too fancy. Everything looks very boring so far. So I'm going to write a very quick popular interview question. The fist busting.
Oh, okay.
So this is how people should write this. You have a loop. You have if and I do not need to write this, do I? Yeah, I should know what's happening next. Alright, that's a long is plus if I actually, yeah, it's very boring.
I always like to do the organic style.
Please stop. Sorry? What?
The fish bus line, this one.
Oh, the column. Yeah, I feel my interview.
Where's Rust form?
Okay.
Rust form.
So
yeah, I know, right? Rust form. Yeah.
Then I would like to introduce another way of writing the branching. You can choose not to write if statement if you really hate it.
Which is like a switch case.
Kind of like a switch case, but it's actually not. It's more like a pattern matching thing. So it can match.
Oh, that's nice.
Yeah.
Oh, that is quite beautiful.
Oh, wait, you can just debug outside. You can just put one debug outside, everything can be done.
Yes. Yes, I know. Yes, I know. That's the reason I do this way. Calm down, man.
Yeah, exactly, right? This is very nice.
And the good thing about this is that if you miss out any case, The compiler will tell you.
Really?
Wow.
Yep. Like for instance, if I leave out the false and false,
So it really enforces a
Yep.
table of sorts.
the compiler should do a lot of complaining.
I mean, it did do a lot of complaining, but I think not for
No,
the
because
reason that you said.
Good. Oh, doesn't be common, isn't it?
No, it's saying found text, there expected type.
Oh yeah, because I made mistake. Yeah, I failed my interview again.
No, it's still the same error, yeah. Are you supposed to define the return type?
Or what if we put the map column, a semicolon in the map after the match?
Is that like a function, basically, the that's being run after?
Sorry, which one? Yeah, the
nice.
last pattern is not common. So it enforces the track, so you will not miss your track. Alright. Sure.
So why you do it this way? You don't check equal to 0, you just put same one just now.
Sorry?
You don't put equal to 0, yes. Show them matching. You don't put equal.
What code is 0? What equals 0?
You don't put this.
Yeah.
You don't put equal to
check
0.
against true, so it should be.
No, check against number. It will be number.
Now, if I track
No,
number, it
So
will
your table should be 0, 0.
Yeah, you can see the pattern matching. That's when it is useful.
yeah, if I don't do this, it will be a lot more complicated and it would not be as clean as this. So it will be 0, 0, and this is 0. This should be 0. Then
What's the other?
you need to write something like this: if I is not 0.
But it will definitely be 0.
Okay.
Yeah, it will not be as clean, but yeah, if you don't want to put 0, 0 like that, yeah, this should work too. J, if I is not 0, yeah, which makes it, yeah, I prefer it this way. Yeah. This is the intended. This is the intended way. Yeah, I just left out the equal to 0 part.
Yeah.
Okay. Okay.
So for this kind of pattern, mostly is like using true false thing or maybe like a string kind of thing.
Like I showed you just how you can use numbers, but you can also use string if you want to.
But I'm guessing string, they won't have any way to like tell you which
It will
which
be-
cases are not.
Usually when you write match, it's either for this kind of cases or you have, I mentioned some, the none as well.
Right.
So none, some cases like this. It's good to check when you have enumerations, enums. Yeah, but I won't be covering enums here today. Yeah, but if you have enums, it's a good candidate for pattern matching. But because this is so powerful, people use this for everything. So I'm not a fan of abusing match in cases where if statement is more obvious, but yeah,
That's so nice.
yeah, it's kind of nice. Yeah. Okay. Well, whichever that you find like you like. You can also write loop in different way. So if you come from functional background, you may find this very, very, very helpful. So you can have map, reduce, and filter. So this is how you write a small closure in Rust. So
This is the equivalent of that.
yeah, lambda. This is how a basic lambda looks. So as I mentioned just now, Rust always return the last expression. So you can actually admit omit the outer braces if you intend to return the last expression. So this is equivalent to this. I return. So you can like save a few characters by doing this.
Flash doesn't need a bracket flash.
Yeah, because I'll do this. I will need to return this.
Does Rust chain by default?
Sorry?
Does Rust chain by default?
Certain methods allow you to chain together like this.
Okay.
Yep. Everything has to be in the same.
But you can just return the str, right?
If I return str, this will not work. The last one.
Oh.
Yeah.
You can cast it to SCR.
Format another macro.
Okay, just use string form also can.
Yep. Just try to introduce a new one. From quick. So it returns a string for every. Then because if you write iterators like this, Rust by default does not evaluate until you call a collect or you call for each. So if you want this to be computed, you need to call either for each or collect. So in this case, I just want to print the result out. So this should do.
Is for each,
Oops. Yeah, sure.
is for each guaranteed to be in order?
It will be in order because this is not done in parallel. So it's done in sequential. If you want it to be in parallel, you need to import some crates, different XML crates in order to do that.
Oh, .NET is not automatically in parallel.
No, it's not in parallel by default.
Parallel, you just need to PAR underscore. And then yes.
What do you mean?
The crate.
Oh, okay, the crate
You
PAR
need,
underscore.
yeah, you need another crate for the behavior. By default, whatever that ships in the standard Rust is sequential. So the order is preserved. Okay, I think is any more that I want to show.
So if you want to like write multi-core type stuff, you need to
import another crate.
Yeah, so the enumerate. Or what? So the enumerate.
Wait, enumerate. But why?
maybe you should be running teaching doing this instead.
Yeah, you can also do this instead, like directly print instead of doing a map. Separate maps now, but I'll not be showing that. Okay. Now let's talk about borrowing. I will briefly talk about copy types. Copy type is just like something that implements certain behavior that allow things to be copied instead of. There are usually things that are very easily copied. It can be easily copied that does not take too much time, and things that can be easily allocated by the compiler. So if you have a huge string or a huge resizable vector, then they usually don't implement copy because it will take time to reallocate new space in the heap.
Understand? copy and clone copy.
What is cloning? Copy. Yes, that's what cloning.
No, I haven't called about clone yet.
But copy involves moving things from stack to heap.
No, it's just everything happens in the stack.
Okay, got it.
So there's no huge allocation in heap. So therefore, copy is only implemented in things like numbers, all the scalar types, the numbers, the float, and the things that you know the size, like for example the string in this form,
Okay.
and this type of array.
So the compiler can calculate it and leave it in the stack, and then but once it figures out that it's not in there, then there won't be a copy trade.
Yep. You can see it that way. Yep.
Well, usually copy is for the individual because there's copy, there's code, and copy, everything that is copy also implements code. So copy, why they use copy? Because copy is the same, cost the same as code. So they can just copy the variable.
I give up trying to type. So I'll be just copying. Sorry?
Did you see your key is pink?
My key is pink.
Key.
Pink? Oops.
Yeah.
The background is pink.
Oh, I don't know.
Or maybe everything is a red team. Is it flux? Like,
Oh, the nightshade thing is on. Yeah. Okay, so therefore, borrowing is actually not applicable to things that can be copied easily in the memory. So I'm doing a quick demo on how borrowing works. That the Rust people are talking about, like in every single like presentation that they do. So let's start from something like you define something that is borrowable. So it can be a string in this case. Then let's say I want to have something that is stealing from this will not work. This will throw me an error. Because the ownership, they call this ownership, is now, the value here is now owned by this variable.
okay.
Because because the ownership moved from this.
So you can't assign to it anymore?
Yeah, you cannot.
Can you print it?
You cannot.
Oh, so
You cannot refer to this.
it by its own name anymore.
Yeah.
One
If you want the value, you need to get it from this.
So then it's not borrowable.
It's an ownership. It's a haven't come to borrow yet.
Okay.
It's ownership.
This ownership. This is a very basic demo of our ownership. Okay.
But since the string didn't change, is that mutable thing needed?
No, I guess it's not needed, but
Yeah, it's
I
not
guess
needed.
it's just specifying it as a string. Like, it doesn't matter.
No, it really doesn't matter.
Wait, but if it's mute, isn't it not on the stack that it should be on the heap, right?
No, it depends on the type.
Mute is just specifying that it can be mutable.
Okay.
You can mute it just like that.
Okay, I see. So that actually doesn't, the compiler, it doesn't affect the compiler where it decides to put the value.
Yeah, it still depends on the one is correct.
Okay, got it.
So the ownership changing also applies to function calling. So this will not work also, because the value is gone. This reference is not valid after thief received the ownership. Yep. The ownership is passed into the function. Right. And the helpful compiler will show you an error saying the value is borrowed here after move. The move occurs. Moved inside the function, move into the function.
So it's almost like the value is being passed.
Sorry.
The value is being passed by, it's not passed by value, it's passed by reference, kind of, and then you can't.
Kind of is not the reference system that you are used to in other languages.
Yeah. So it all still points to the same thing, right? You don't actually just talking about it. Yeah.
No, not everything points to the same thing. The pointing thing moves from the original one to this once you pass into this function.
Because what does it become? Does it like come now or do they mark it?
This now refers to it, right?
Yeah, this is refers to it. So once this function is done executing, no one is pointing to the value anymore, because this is not pointing to the value. And then the function already finished executing, and then the references are all dropped. Sorry. If you want to retain ownership, yeah, you need to do something. Yeah, one way is to return the value, or you can do borrowing. Then do actual borrowing. So if you want to borrow, this is something that is similar to other languages, but yeah, there may be some differences. But I've not been dealing with references for quite some time since. Yeah, it's similar. Yeah. You just pass in the reference so that the original one still has the reference to the value. So this one will not work.
Okay, so it's kind of like only one variable can hold the pointer to the value
at the same time.
At one time, yes.
Not like that.
No, not actually, because of the way they implement this, so you can have a lot of things holding the reference to the value at the same time. Because no one has the ability to mutate the value.
So that
even this is
mutate.
But if I do not give permission to mutate when I throw it into a function, it will not be mutated.
Okay, so can you show them how is that?
Okay, so
calm down.
So the whole idea behind this is kind of almost like control on who can mutate.
Yes.
Even so, you may be able to read the value, but you cannot mutate.
You cannot.
You don't have the
If you want mutation to happen, it needs to be defined here. You will have a mute here. And
you put mute. Even though that mute up there.
You also need to explicitly say it is mutable.
Oh, it's like you put the mute on the reference, not on the.
Okay. You have to be explicit when you want things to mutate your value.
Sure.
Right. So yeah.
So this is where all the safety.
So this is like I say, you can let a lot of people to mutate. I mean, read the data at the same time. But
without the ability, right?
Yeah. But no one has no one can write. So you can have this problem.
Use the bin add-on for a case.
Sorry?
You use the Bing add-on.
Yes.
So, yeah.
Yeah, too used to Bing, so everything is Vim to me. So if you want to write yeah, like I say, you need to be explicitly specify when you pass it in. You also need to.
Multiple things can hold a reference to the value, right? So multiple things can
Only one can have the writing right.
Oh,
Yes.
so when you pass the mute that way, it goes away from the global one.
Maybe I say the rules. There's 3 rules for ownership. The first rule is there can be multiple reference at the same time.
Okay.
The second rule is there can only be one mutable reference at one time.
Okay.
There can only be one holding the mutable reference.
So once this takes it, then
nobody else can have the right access to the reference.
And there's a third rule. The third rule, both of them cannot be used at the same time. So you can either have reference or you have mutable reference. You cannot use both at the same time.
Oh.
You cannot read and write.
Yes.
So you can write.
So once you have a mutable reference, all other references to it are broken.
No, you cannot do that. You scream. Come on, scream you.
Okay, so you cannot do what he's just done here, where you have this.
Yes, I can, because this is all happening sequentially. If you
Right.
have things in parallel, then.
Okay, got it. The word vulnerable has lost its meaning to me. You know how when you see a word over and over again and then like it loses its meaning?
Yeah, practically, this is it. The warnings.
Very, very hard.
Yeah, the mutable is this is not needed because it's not the compiler is trying to be the compiler is trying to be helpful. So some people might find it helpful. This is the WSL thing. This is a WSL thing. I've not seen this elsewhere.
Okay.
Right. Yeah. Basically, this is a very quick introduction to the ownership rule. For the worst case scenario is if you don't want to deal with ownership, just use clone. Everything that is not implementing a copy trait usually implements clone. Yeah, it will be slow, but yeah, if you don't want to deal with the ownership thing, like for example, when you're just
clone is like copying
it's like copying, but yeah, about the same thing, but it's slower.
The copy and everything.
Yeah.
Oh, okay.
It will be run.
But coming from Python, I don't see it slower.
Yeah, the slowest function in Rust is still faster than Python.
Yeah. Yeah, it's supposed to be efficient, but usually when you start programming in Rust, you start by cloning everything, then you start reducing the use of clone over time. So it will be easier that way.
Okay.
Yeah. So that's it for today. Anything you want to
enumerate?
What good extensions are there for Rust?
Sorry?
What good extensions for that Rust today, I guess? Or do you
I'm only use the very basic official.
You don't even have the language installed. Okay.
I'm so sure you saw this.
Not needed.
Yeah, I'm sorry. Yeah, you should be installing this.
Okay. Then you did it.
I forgot because I haven't set up the development environment on this machine yet. I just got it like last month. Yeah, I should be installing this because it bundles some tools. Like the more useful one will be the formatting, auto formatting.
Yes.
Yeah, you should be installing this. Yeah.
Will it warn you if you're
Because it has a language, so it should do that.
Yeah, you should put errors and studios.
what other cargo packages use on?
Well, Rust is not my primary language, so I usually just use it to write useless things. So I don't really do productive things with Rust. I only do so far only exorcism exercises with Rust.
Exorcism.
Exorcism.
Oh, okay. That's a very dangerous word.
Yeah. They, if you want to start learning, they do give you a very good overview. They do force you to learn different aspects of the language through the main track, and then you also get to interact with the mentor that sign up to help. So these are all the exercises that I have completed.
Yeah.
So they have different things, exercises. So you'll be writing this, and then you will have feedback from your mentor.
How easy is it to write like CLI type stuff with Rust? Like, does it have native support for taking in input from the CLI arguments and all these kind of things? So it's not native. You have to still install a package.
You can do without package, but
Okay.
the package, everything will be generated, even the competition will be generated for you.
And then how far are you from writing your own kernel with Rust?
There's already one results.
Oh, okay.
There's some guy writing the operating system with Rust. Not sure about the progress. So that's it. Does someone have anything to ask?
You ask question.
What is the most confusing concept to you with Rust?
Borrowing and lifetimes. That's why I'm not covering lifetime today.
But you get to learn it right now. Now you understand it, right?
Not really. It's still the thing that bugs me a lot. Yeah, but over time you develop some sort of intuition, like how things are supposed to be. So you will be able to figure out a way to make things compile, and then if it compiles, then it should run. It gives it that kind of very weird, like assurance when you write program in Rust. Yeah, but I really don't see it as my primary language like for another maybe a year, because I really, yeah.
You still prefer C?
I still prefer Python.
Okay.
Yeah, I'm a very dynamic programming person.
Here there's a quote of the week explaining this. Python and Go pick up your trash for you. C lets you litter everywhere, but throws a fit when it steps on your banana peel. Rust lets you and demands that you clean up after yourself. Yeah, quote of the week.
They could have just summarized that as Rust is your mom.
Well, I come from Python, I'm very spoiled, so
Yeah.
I don't care. I like NumPy.
I'm offended at JavaScript. It's not that, but okay.
JavaScript is whole different.
No, JavaScript doesn't just let you do everywhere. JavaScript will help you. Oh my god, everything is so wrong.
Okay. Any more questions that you want answered?